Hello, welcome to the free response question of the day. Today we're going to look at the 2010 number 5. So let's see if we can figure this one out. So this one says, now by the way, this is the sort of thing that I think on this year's exam will be emphasized, doing an inference like this, and we'll chat more about that momentarily. But anyway, a large pet store buys the identical species of adult tropical fish from two different suppliers, Buy Right Pets and Fish Friends. Several of the managers at the pet store suspect that the lengths of the fish from Fish Friends are consistently greater than the lengths of the fish from Buy Right Pets. Random samples of 8 adult fish of the species from Buy Right Pets and 10 adult fish of the same species from Fish Friends were selected, and the lengths of the fish in inches were recorded as shown on the table below. So there's the lengths of the fish from Buy Right, there's from Fish Friends, there's their mean and standard deviations. Do the data provide convincing evidence that the mean length of the adult fish of the species from Fish Friends is greater than the mean length of the adult fish of the same species from Buy Right Pets? So if you want to pause the video and see if you can do that one. Okay, so this one, okay, they ask, do the data provide convincing evidence of something? That means it's asking for a p-value. It's asking you to do a hypothesis test. Is there convincing evidence? And when you're dealing with these samples, and you also clearly note this is definitely quantitative data. Two lists of numbers like this. It's definitely not categorical. We have means and standard deviation. So remember, means is t. So, and we have two samples. So this is a two-sample t-test, pretty stock two-sample t-test with pretty small sample sizes. So do we have convincing evidence? Well, we're going to perform a test. So we have to do the THAME acronym. In other words, the type. We have to state the type of inference, the hypotheses, check our assumptions, do the mechanics, and then do our ending. So the first thing, the first part of the answer is state what you're doing. The type of inference is a two-sample t-test for means. That is the name of this procedure. Then we have our hypotheses. So our null hypothesis will always be the two means are the same. The alternative here is that, and of course define what mu sub b and mu sub f are. Mu sub b is the mean length of all the adult fish of this species from Buy Right Pets, and mu sub f is the mean length of all the adult fish of this species from Fish Friends. And so the alternative, we went with less than here because it clearly said, actually a couple times up here, that they suspect that the lengths from Fish Friends are consistently greater than from Buy Right. And so the Fish Friends was the second one, and then it clearly said it down here that the species from Fish Friends is greater than the mean length from Buy Right. So that is why we went with that there, is the Fish Friends to be greater than Buy Right. And so that's how you state your hypotheses, clearly defining your parameters there. Of course, the other way, once again, of writing this, you could have written this as, and a lot of times you'll see this, mu sub b minus mu sub f is equal to 0, and then this could be written as that mu sub b minus mu sub f is less than 0. That's just subtracting mu sub f from both sides. So either way is fine, and you'll see it written both ways. And so then we have our assumptions or our conditions. All right, so that is our sin, or our I-sin, since it's two samples. It clearly says that random samples were taken, thus independent random conditions met. Remember, with the two sample things, you have to say independent random samples were taken, like that. There must be at least 80 of the type of fish from Buy Right and 100 from Fish Friends for our population size to be at least 10 times our sample size, because we aren't using replacement here. We're using sampling without replacement, and so we have to have this in order to have independence in our two samples. And then we have our normality, and so for normality, we would have normality by the central limit theorem if our sample sizes were bigger than 30, but they're not. Or if it said in the problem that things vary approximately normal, but it didn't say that. The other thing is this: we look at the sample graph. All right, as long as we don't have outliers or strong skewness, we feel that normality is reasonable. And you always want to graph your sample data if you can, if you have access to it. So, and then both of the sample graphs show no outliers nor strong skewness, or normality is reasonable. So that is your assumptions, and that, I feel there's a really good chance that's going to be asked of you in this year's exam to I-sin like that. But anyway, and then we do our mechanics. Now, so our mechanics is this. There's our formula right there. Let me remind you, on your formula sheet, this is a little bit unlikely. A formula is unlikely to be on the exam this year. But remember, for whenever you're doing a test, you have to do a test statistic, standardized test statistic. And so it's statistic minus parameter over standard error. And the standard error is on the next page. And then for means, the standard error is going to be that guy there. That's for one mean and that's for two means. And so that's the one we're using here. And so those are those values. And now, but the way we're really going to do this is by using our calculator. And so you use our calculator, this is what we'll do. We'll enter our data in list 1 and list 2. So we'll enter all of these values, all the by right ones in list 1 and all the fish friends in list 2. So we would go stat, and then we would go edit. And so I put all of the by right in list 1, all the fish friends in list 2. So then what we'll do is this. After we put it in, we go stat, and we go test, and we go down to 2 sample t-test. There's the name of our procedure. And so we're using data, so we hit in data. And you could actually use stats on this. If you use stats, you would use, this is your mean, and this is your standard deviation, and there's your sample size, 8. So anyway, but we'll use data since we have access to the data. I put them in list 1 and list 2. Frequencies are 1 or leave it blank. The alternative is less than. And so we always say no to pooled whenever our calculator asks us. And so then we go calculate, and there are the 3 numbers we have to write down. There's our t-test statistic, our p-value, and our degrees of freedom. And so that is what we have to write down here in our mechanics right there, our t-test statistic, our degrees of freedom, and our p-value. And then, so that's our mechanics. And lastly, our ending, drawing our conclusion based on our p-value. And we would say this p-value is greater than 0.05, so I fail to reject the null. We do not have convincing evidence that, and you restate the alternative in context, which is that the mean length of all the adult fish of this species from by right pets is less than the similar mean from fish friends, okay? And so now, having said all that, on this year's exam, what's going to be emphasized is this, doing a proper conclusion from a p-value and checking your conditions and this. The mechanics here, there's a really good chance that they're just going to give you a p-value and give you a test statistic, okay? They're just going to give you the mechanics, and they'll ask you to do the last part and then, the top part here. Okay, to me, it's what's going to be emphasized. Another thing could be asked of you would be to interpret that p-value. This is the conclusion from the p-value. To interpret the p-value would be to state it as a probability and saying, well, and then the probability is this. A p-value is the probability that you get sample values this unusual, assuming the null is true. And so interpreting this p-value, you would say, assuming the null is true. In other words, assuming the mean from by right is the same as the mean from fish friends, the probability that we would get sample means is unusual as these, as different as these, okay? Or in this case, that this one would be this much bigger than that one, all right, is about 0.4, 0.39963. And so that is stating your p-value. Of course, the other thing you could be asked to do is to create a confidence interval and connect the confidence interval with the null hypothesis, and comment on the fact whether the null hypothesis value, which is 0, whether or not it's in the interval, and it should be in the interval here, since you have the high p-value, which we've done several examples like that. Okay, that's it. If you have any questions, please send them to me. Thanks for watching the video, and look forward to chatting with y'all again soon.